Hi, we're the Beige Oranges. My name is Dimitri.
I'm Roy.
I'm Chang.
I'm Savon.
I'm Mark.
And we are here to introduce our event coordinating management system software that we designed. So our problem was we decided to use a real-life application. At Hi-Res Studios, I'm the event coordinator there, and we actually do have a problem with our software. We utilize a software called NAC, and it's very redundant, hard to use. When players would try to log in, it actually wouldn't let them log in correctly unless they had a Gmail. That was a big problem for us, especially since a lot of our players are international. And also we ran into a lot of problems with people just not being able to use the system correctly, like import their travel information and get to it in a singular space. It was spread out across multiple platforms, and our software will actually bring it to one, which would make it very useful. Now, also our planning and scheduling for our system was developed in the very beginning. So we decided to use the plan-driven system and use the waterfall part of the plan-driven system to decide how we were going to plan and schedule everything. We also utilize GitHub and Slack. That's the way our team actually communicates and how we push all of our coding into one. And also Slack helps us communicate in a way where we are clear and everyone understands what is going on. And now we'll go to Roy for the requirements.
So now I'll talk about our requirements. First, we'll talk about how we came to our requirements. So like Dimitri said, she works for Hi-Res, so she's kind of the subject matter expert when it comes to this domain. So we had a real life business case where we could reference and have her as a point of contact on how we built our requirements. And so we also kind of use a subject matter expert, and we also use kind of an observation model because we had an active as a reference. So we kind of observed how the workflow was represented and what functionality we needed to replicate. So in terms of our context model and how our system is it exists in relation to its environment, we have the booking flights, so that happens on external system, whatever flight airline company that the administrators use to book flights. We also have travel and hotel systems that the admins use to make and register flights for the players, so they can have that information to them in our system. So those systems kind of interact with our system in that way. In terms of our use case, we have mostly three main actors. So we have the players, admins, and then our database is another actor. And our environment is our application, which is the ECMS. And so all our use cases you'll see listed kind of exist in that environment. And so for our class diagram, in terms of the modeling aspect, the way we went about making the class diagram was looking at the requirements and looking at nouns to represent classes and deriving our classes that way. And that's how we kind of arrived to our initial system modeling aspect. All right, so now Chang is going to talk about the design aspect of our application.
So as you can see from our system architecture, we really built the system around the admin board and the player board. To start out the system, once your login and account is verified, you're determining whether you're a player or an admin takes you to your designated dashboard. Say if you were a player, you go to the player dashboard. You're confronted with a list of events. You can view the events. You can also view your flight information, and you can also edit your profile. If you were to log in as an admin, you'd be confronted with the admin dashboard, which lists all your events that you've created. You can enter your events and invite the players that you wish through email. It also has other functionalities such as uploading the travel information and viewing all the confirmed players. Okay, so moving on to our class diagram, like Roy said, they were built upon our requirements, but they were really refined once we made our sequence diagrams. Because our sequence diagrams made us lay out the system realistically, it helped us understand how the system would be executed. For our design pattern, we did have one instance of it, which was a creation of singleton, and we used it for the email validator, which worked along with our registration. Now on to Mark for implementation.
Yeah, so implementation, as far as languages we used, we did write in Java, being most of our primary language. We did take a couple of gambles as far as tools we hadn't used, though. We used IntelliJ for our IDE, which none of us had ever written in before. Was a joy to use, though. We also created our project using Spring Boot. It was a Maven build, but we did use certain dependencies from the Spring core. We used Spring Session, Spring Web, MySQL dependencies, and Timeleaf we actually ended up using so that we could write the front end in raw HTML as opposed to doing something like JSPs. The other tools we leaned on heavily were Bootstrap for that UI design on the front end as well. So if we look at the project structure, right up at the top you're going to see a configurations package. That holds all of our configuration files for the Spring core. So that allows us to configure a lot of the ways Spring dependencies work inherently in our system. Underneath that, you'll see the controllers package handles all the mapping for the site as well as the transition of data from one page to another. Underneath that, you'll see our DAOs, or data access objects, mappers, and models. These three together serve as our transition of data from our database tables into our models or instantiated objects. And under that, you'll see our utilities package that holds our password encryptor and a couple of other things in there as well. Now, if you'll look at our database model, you'll see we have a users table that holds all of our users data, an events table that holds all the event data, a registered to table that references those two, a role table that Spring Session and Security uses to parse roles to the two separate sides of our website, the admin side and the player side. We also have a travel info table that maps individuals' travel info per event, and a Spring Session table so that Spring can track individual user sessions inside the site. And now on to Salam for testing.
So for our application, we had a lot of automated and manual testing to see our bugs. An example of that is adding a player to an event that a player is already invited to would always just throw us an SQL error. Another test we ran was attempting to create a user with a missing info such as name or email, which would give us an error message in every line. We also wrote a lot of white box tests to test our code, such as creating users, editing user info, and finding user by email to invite to events and more. In conclusion, ECMS is a system that solves the problem of event coordination and communication between admins and players. We used a lot of SQL, Java, with Spring Framework and Bootstrap and such to implement all these features. Okay. And we tasted a lot to refine our system and see our bugs and fix them. Thank you for watching, and there's no see you in the next video.
Yeah, there's no next video.
No.
That's it. So, bye guys.
Bye.